Hi everyone, Jun Rao from Confluent here. In this module, we're going to talk about Kafka elasticity. Kafka is designed as a distributed system. So one of the strengths, it allows the system to be scaled out and scaled in as you need it. So if you are adding new brokers or removing brokers, one of the things you have to do is to balance the load among the brokers, because the new brokers may not have any data, right, to start with. So in this case, you want to be able to shift some of the load from the existing brokers to the newly added brokers. Another reason why you need to move some of the data around is sometimes over time, the load amount of brokers can be unbalanced because the exact amount of data across those topic partitions are not even. Now let's look at some of the ways how do you balance the data among those brokers. The good news is if you are using a managed service like Confluent Cloud, this is actually done automatically for you. So you don't have to worry about balancing the data yourself. Next, let's look at some of the tooling you have if you are not using a managed service like Confluent Cloud. The first tool I'm going to talk about, this is actually available in Apache Kafka. It's called Kafka Reassignment tool. So the way it works is if you want to move the data around, you first compose a JSON file to describe what are some of the replica assignment you want to have for each of those topic partitions. And once you have this JSON file ready, you feed that into this command line tool and then execute it. And then once the command is executed, the broker will try to move the data from the current replica assignment to the new one over time. So while this tool gives you pretty good flexibility, you can control exactly what set of topic partitions you want to move around. It tends to be a little bit manual. So you have to manually prepare this JSON file, and this is actually not convenient for a lot of users who are not really Kafka administrators. So another tool we have is actually from Confluent. This is called Auto Data Balancer. So it improves the partition reassignment tool by automatically generating that new execution plan for you. So when you run this tool, you don't really need to specify that JSON file. You just point that to a Kafka cluster, and then the tool will look at some statistics across those brokers and then generate a plan automatically for you, and then you can run it. So this is actually improvement from the previous tool, but it still needs to be manually triggered. So the latest tool we have from Confluent is called self-balancing clusters. This tool improves auto data balancing by automating the process of data movement. In this case, you don't need to, you no longer need to run those manual tools. Instead, self-balancing cluster monitors the cluster constantly and it will trigger the balancing automatically as it fits. And when it generates a plan to move the data around, it can also generate the plan in a much more efficient way to reduce the amount of data movement across the brokers. Let's take a look at how SBC works in a bit more detail. What's happening is when SBC enabled, each of the broker will be running a little bit SBC agent. It's responsible for collecting some of the metrics on each broker, such as how many leaders are in this broker and how many messages or bytes have been written to each of those topic leaders. And all those metrics will be collected in an internal topic, and then the controller node for SBC will collect and aggregate all those statistics and make a decision based on those metrics to see whether there's enough balance among those brokers, and if so, it will generate a plan automatically for you. SBC makes decision to trigger rebalance on roughly two goals. The first one is if there's any changes in the broker, if some brokers are added or removed, that's an opportunity for trigger the rebalance. Another thing is if it senses any imbalance of the cluster. And that imbalance is determined based on information such as the leader, the amount of bytes, and the amount of bytes written, the amount of bytes read as well. So when it generates a plan, we'll try to generate a plan that minimizes the move and also takes into consideration things like rack configuration, leader distribution, and other things. And while the plan is being executed, SBC will also automatically set up a throttling so that the movement doesn't overwhelm the ongoing client request. If you're running SBC with tier storage enabled, the moving of the data will be even faster, as I mentioned earlier, because in this case, the majority of the data will be stored in a remote object store. And when you try to add new brokers to move data to this new broker, the remote data don't need to be physically moved because it's only the references that need to be moved. So the rebalance in this case will be much faster. The last thing I want to talk about in this module is some of the consideration for the local storage. For some of the use cases, you may need to have multiple disks volumes associated with a particular broker. In this case, you have a choice to expose them either as individual disks, which is the JBOD model, or as a RAID. In the RAID case, we typically recommend RAID 10. So the JBOD model gives you an ability to use more storage, but it adds a burden that you have to think about balancing the load or the amount of data among those individual disks because you don't want them to be uneven. With tier storage, this choice is made much easier because the majority of the data will be stored in a remote block store. The local storage need is actually much smaller. In this case, the typical recommendations, you will just use all the disks in a RAID 10 mode and use that for storing the local storage. And that's it for this module. Thanks for listening.